morning. Today we are going to see Laurent series using design thinking approach. So what is a Laurent series? It's an infinite series. Very good. So Laurent series is nothing but it is a complex function used to interpret the infinite series, and we are going to use design thinking concept for this. So let Darshan explain about this.
Yeah. So before getting into the topic, let me explain what is design thinking. Design thinking is a human-centric approach and it's a problem-solving statement. There are 5 basic principles in design thinking. They are empathy, define, ideate, prototype and testing. Empathy is the actual problem which we are having, and define how we can solve it, and ideate is the model which we are going to do. So here we are having a problem that for Laurent series we can use the Laurent series in calculating the medical imaging and the MRI scans. So in this session we can discuss the MRI scan connected with the Laurent series. So for the MRI scan value, we have a value that proposed result is equal to 7z minus 2 by z into z minus 2 and z plus 1. I need to find the value of z where I can find the MRI scan value. So for this I have a condition for the modulus value.
Mod z less than 2.
Yeah. Then mod z less than 2. It's the actual value. But we are having here this z. The question we are having here is mod z. So this is the problem which we are going to solve in the design thinking manner. So let me start with the question, right? It comes with z minus 2 and z minus 1. So let me do partial fraction here. So 7z minus 2 by z into z minus 2 and z plus 1.
So how will you split this using partial fractions? Anyone of you?
It's type 1 condition. So we can use a by z, b by z minus 2 and c by z minus 2.
Very good.
So a by z, b by z minus 2 and c by z plus 1. So we have here, let me take LCM in this process, that is 7z minus 2 by z into z minus 2 and z plus 1 is equal to a into z minus 2 into z minus z plus 1 and b plus z into z plus 1 and c z into z minus 2 by z minus 2 and z plus 1. Here, denominator cancels and we have the separate value, that is 7z minus 2 is equal to a into z minus 2 into z plus 1 and b implies z into z plus 1. C implies z into z minus 2. So, by substituting the values for z, we can find the a, b and c. Can you tell me for substituting what value you get?
We can substitute 2.
Yeah, we can substitute z is equal to 2. By substituting z is equal to 2, this a part becomes 0 and the c part becomes 0. We can find the b part. That is 7 into 2 gives 14 and 14 minus 2 gives 12. So 2 minus 2 becomes 0, so the total a part becomes 0. As same, here the 2 minus 2 becomes 0, the total c parts becomes 0. So substituting the z in b part, that is 2 into 2 plus 1, it's 6b. So 12 gives 6b, we get the b value equal to 2. Right. Fine, we have found out the b value. Next we are going for the a value. For going a value, we can substitute for minus 1. By substituting z is equal to minus 1, we get a becomes 0 and b becomes 0. We can find the actual value of c. That is 7 into minus 1 becomes minus 7 and minus 1 minus 2 becomes minus 9. So minus 1 plus 1 becomes 0, the a part totally becomes 0. As same, minus 1 plus 1 becomes 0, the b part becomes totally 0. So using the c part, minus 1 and minus 2 is minus 3. Minus 3 into minus 1 gives plus 3. That is 3c. So c is equal to minus 3. Finally, we have found two values, that is the b and c. At the last, we have to find only one value, that is the a value. So for finding a value, I can use z is equal to 0. By using z is equal to 0, the b value becomes 0, the c value becomes 0. I can easily find the a value by using z is equal to 0. So we have found that z is equal to minus 1 and z is equal to 0 gives minus 2 and 0 minus 2 becomes minus 2. 0 plus 1 becomes 1. 1 into minus 2 gives minus 2. That is minus 2a. So the final value of a is 1. So finally we have found the three values, it's a, b and c. We can substitute here the values. That is 7z minus 2 into z into z minus 2 into z plus 1 is equal to a value is the minus 1. That is minus 1 by z.
A value is 1.
A minus 1.
1.
A value is 1.
So a value is 1 and the b value, this is 2 which we have found out. It is 2 by z minus 2 and the c value is the minus 3. Minus 3 by z plus 1. So we have found out the a value, b value and c value. Actually I want is the z value. So for the z we have a condition here, that is mod z less than 2. So the mod z less than 2 can be written as mod z by 2 less than 1. It's the linearity which you are having in this sum. So that means I need to take care of the 2 where I can get the mod z by 2 linearity. That is 1 by z and 2 by. I am taking here the 2 as a common value. So I am taking 2 as out. It gives z by let me take as minus 2. Yeah. So it gives me 1 minus z by 2 where the linearity becomes best. Yeah, we recognize z by 2, so we have taken as z by 2. Just keep it as z plus 1. So I am rearranging 2 becomes cancelled and minus. This denominator when it comes to the numerator, it becomes as inverse. That is 1 minus z by 2 inverse and 3 into z plus 1 and inverse. And it's a formula for the
Binomial expansion.
binomial expansion formula. So for the 1 minus z by 2, what's the formula which will become?
So by binomial expansion, we can expand this as 1 plus z by 2 plus z by 2 the whole square.
So it may be z square by 2.
Yes.
And so on, it may become we can do and so on values. As for the same, we can do this z plus 1.
So
z plus
expansion
1.
of 1 plus z whole inverse.
1 plus z.
1 plus z whole
1,
inverse.
1 minus z.
Minus z.
Yes, you have to start
It
from
comes
minus z. So
alternate.
1 minus z plus
Plus z
z
square.
square minus.
And so on the values will be. So finally, I got the value for the mod z by 2. That is, I got the value for this where I can easily find the MRS component. Thank you.
Z plus 1 plus z ன்னு மாறுதா டேய்
எப்படி வச்சாலும் ஃபார்முலா ஒன்று
டேய்
எவ்வளவு சொல்லிருக்கீங்க?
என்ன